We are at the University of the West of Scotland's Lanarkshire campus, where we conduct research in support of the United Nations Sustainable Development Goals, and specifically focusing on the development of solutions for the future smart cities. These solutions require digital technologies, require a lot of research in artificial intelligence and automation, and our research is at the cutting edge of those efforts worldwide. The smart cities of the future potentially are more vulnerable than the traditional cities that have lower levels of connectivity. And what that means is that we need to develop the solutions that enable very rapid response solutions to be there when the disaster strikes, that enables all the systems that are in place to continue functioning, but at the same time that enables people to continue being connected. So one of the solutions that we have developed here at UWA centers around the use of autonomous drones in order to achieve connectivity wherever you are. So we cannot neglect the fact that actually people live and will live within the city limits as well as outside of the city limits, and therefore connectivity is required everywhere.
So we can use these drones to fly to an area where the connectivity is damaged or limited, to we offer solutions or the services to the ground users when there is a disaster or when there is a natural disaster. You can think of these drones as a flying base stations or flying Wi-Fi spots, and they can go there and provide the connectivity to the users. And these users can then use their mobile phones to let their friends and family know that they're fine and they're doing well in case of any flooding or any earthquake. Our vision is to transform the concept of 360-degree automation in various real-time settings to improve the connectivity and resilience in the network and produce the skills and build capacity in the country. And that is healthcare networks, water or energy distribution networks, hospitals and transportation networks that actually basics are key to run the life in the country. If anything happened, for example, there's a disaster or there is a malfunctioning in a network or in an infrastructure, or you can say that it is congested or damaged, then we can have an alternative solutions to pop up those connectivity solutions in near real time. We are using data analytics and sensing technologies to monitor these real-time environments and collect the data in real time, store these data in cloud computing services, and then learn from these data analytics, apply artificial intelligence, and train our algorithms, smart and intelligent algorithms, so that we can predict future, we can detect some anomalies about these environments and create some alerts.
So one of the key areas that we focus on in terms of achieving autonomous drones is to develop the capability for them to be able to navigate, but also understand their surroundings and their situation, in particular hazard perception. When we introduce drones into an unknown situation, we need to have very robust and reliable artificial intelligence that can mitigate the likelihood of air-to-air and air-to-ground collisions. For example, we need to be aware of other drones that are operating in the airspace, potential incursions from uncooperative helicopters and light aircraft, as well as being able to detect and avoid uninvolved people and vehicles on the ground. With aerial drones, to make them autonomous, all the navigation, the path planning and the hazard perception needs to be performed in real time on the drone itself. We need to use sensors like thermal sensors, LiDAR, radar, high-definition cameras, and couple them with high-performance artificial intelligence that can understand the scenes that are being fed to them in real time. One of the key challenges with this is the decision-making needs to be reliable, so it needs to be trustworthy. Artificial intelligence systems have a habit of being highly confident even when they're not accurate. You see this starting to emerge more recently, where the regulatory environment is demanding that artificial intelligence is explainable and it's trustworthy, especially if the decision making is in safety critical contexts such as autonomous driving and autonomous drones. I think the roadmap here that is agreed by industry and the research community and regulators is we're probably about 5 years off drones operating autonomously beyond visual line of sight in urban and advanced air mobility paradigms.
Fundamentally, it's one thing developing the autonomous drone that can operate in a particular environment, but then there is another matter of creating an environment or developing an environment in which the smart drone can actually safely operate. There is no way you can create a usable smart city without collaboration between the different disciplines when we're talking about the research, between the stakeholders at the city level, stakeholders at the micro level, so communities, the stakeholders between the cities, between the governments, local authorities, with the governments and so on. And that requires a lot more integrated approach, a lot more collaboration. So we are inventing new solutions. But when our research moves into the fine-tuning stage, that means that we have at least achieved the level of development of smart cities that enables sustainable development, sustainable growth, and all for the purpose of maintaining our environment intact and at the same time enabling the inhabitants of those cities to have the best well-being that they can possibly have.